So my name is Monty Thibault. I'm a client developer here at Bluzelle. And up until now, I've done the Bluzelle JavaScript client. And with our new My release, we're going to be releasing a whole bunch of different clients as well. So it's really exciting. Today, what I'm going to be demonstrating is how we can bootstrap Bluzelle caches, many different swarms for the Bluzelle cache in a way that is completely decentralized. And we do that using Ethereum. So here I have my desktop screen, and I'm running a piece of software called Ganache. And essentially what Ganache is it's like an Ethereum blockchain that is running completely on my laptop, and it emulates something like the Ethereum mainnet. So it provides for me an RPC server. Here, just localhost port 8545. This is something that I can do remote procedure calls. I can publish smart contracts and do stuff. So it exposes that for me. And we're going to use that so that we can bootstrap the Bluzelle cache in a way that is completely decentralized. So I'm going to run here a program on my computer called run swarms. And this has two arguments. It's going to have, well, the arguments are numeric arguments, and they essentially correspond to how many nodes are in the particular swarm. So here I'm going to do an example where we have run swarms with 4 and 3.
So Monty, so this script, if I understand it correctly, you're starting two different swarms here because you put two different numbers in, and each number represents the number of swarms. So if I wanted to have a third swarm with 9 nodes, I would just add a 9 after that, and this allows me to run an arbitrary number of swarms, correct?
Absolutely. So I could do a 9, I could do a 13. It's really any number of swarms, because the system that we have, it's really meant to work with any number of swarms in tandem.
Okay, perfect.
Okay, so just for my example, so I don't have too many consoles open, I'm just going to do a 4 and a 3, and I'm going to hit enter, and it's going to pull open all these different terminals, and each terminal is running an instance of the Bluzelle daemon, and the daemon is what's implementing the consensus protocol. So here the first 4 windows constitute the first swarm of 4 nodes, and then the second 3 windows constitute the second swarm, and these are all talking amongst each other, and they'll publish the logs, and they keep all of the information within themselves, and we're able to use them. So if I go back to the original script, you can see that it says that the deployment completed successfully, and it gives us the address of the Bluzelle Ethereum Swarm Registry contract, which is here, and it's highlighted in black.
Okay, that's very interesting. So basically, these swarms got registered to that smart contract running on your local Ethereum blockchain that's running on your own machine, both swarms as well as the, I guess, the IP addresses of all the nodes within those swarms. Is that correct?
Yes. So it publishes entry points to access each of these nodes because they each expose a socket. And it also publishes metadata associated with the swarms. For example, how the information is stored, whether it's on disk or in memory, the country of origin, just things like that.
Okay, great. So basically, Ethereum becomes a decentralized place that any client can connect to, or any node can connect to discover other swarms and connect to them and talk to them.
Yes, absolutely. So the Bluzelle client, what it does is it takes its Ethereum remote procedure call server, which in our case is the localhost port 8545, or in the real case is an Ethereum entry point like in Fura, and then uses this contract that we have to figure out exactly all of the metadata that it needs to bootstrap itself into the Bluzelle cache so that it can use the system correctly.
Okay. Well, thanks a lot for watching our sprint number 37 highlight video segment, and thank you, Monty.
Thank you very much. It's very exciting.